Okay, good afternoon.
Hello.
We are
Good afternoon.
having, I think, a short lecture, so I wanted to use some of this time to just, talk about how things are going, what's happening, what's working, what's not working. So let's see. All right, I'll start in a minute. It's kind of hard for me to find out how many people are participating that aren't coming to these live lectures. How many people are watching these things or going through the notes. So I'll have a survey about that to try to get visibility into it. I can look on YouTube and watch how many times something's viewed, but I don't trust it because I don't know if it's doing, if you watch it on the Canvas link, I don't know if it increments the counter on YouTube or not. I would think it would, but some numbers are suspiciously low. Not just for this class. All right. Well, let's get started. This is going to be fairly quick, partly because it's been a long time since I had to use a configuration control system, and partly because a number of you are probably using them right now. How many of you guys are already using GitHub or some version of Git?
My team is for sure.
Yeah. So we're going to count you as 4 people. Yeah. Yeah, so I think this is really just a reminder that the part of this talk that is more sensible is not so much the tool use as the why do we do this and how does this get used in industry kind of thing. One of the things that students don't appreciate until they experience it, I shouldn't say that, nobody appreciates it until they experience it, is version control. And I noticed that even with something as simple as someone's writing a short report and they've got Microsoft Word and they overwrite their old versions. And then they wonder about things like, oh, I meant to make this change. Did I do it? And you had that change marked in the old version. And then when you got rid of the marking in the new version, it's shockingly easy to get into a version control system, even with fairly simple systems. And as you would expect, I see it in CS225 all the time because students are modifying code, wondering why it doesn't work, only to find out the code they're modifying is a copy of their code, not the actual latest version that they're trying to work on. Or they have code that used to work and now it doesn't, but they can't back it up to get to the old code. So, as you know, you can do that even within Eclipse. You can do our versioning control systems. Microsoft Word, I don't know. I've never used trying to literally recover old versions. I don't know. Okay, so what's the whole point here? No matter what the system changes, this last part is interesting. The desire to change it will persist throughout the life cycle. Now let's remind ourselves what the life cycle is. The life cycle isn't just the development period. The life cycle is deployment out into the real world and post-deployment, the maintenance and upgrade sections of the life cycle. And those are actually the longest ones. So, software is never done, right? The old adage. And I think software in particularly suffers from this problem because if you build something mechanical and you cut metal, you've cut that metal. You can't go back and change that piece. And once you install it into whatever the automobile or the airplane or the building or whatever, that's a hard change. But software being vaporware, right, being non-existent, everybody thinks it's easy to change. And so people are always recommending modifications. I don't know if I've ever yet encountered a piece of software where someone said, yep, it's all done, period, it's done, literally done. It's always, yeah, it's done, but I'm going to change it to do this. I'm going to change it to do that, or I didn't like the way this was done, so I'm going to modify it. And I hope your personal experiences match that. Okay, so what are we doing with software configuration management? You're just trying to manage all this change. You're trying to manage the product. And as you know, as your product gets more complex, you have, and you can easily think about this in commercial products that you know about. You have a mainline product, and then you have a product for customer A and a product for customer B and a product for customer C that do slightly different things. Of course, different operating systems that you have to support are going to be built slightly different ways. So you always have this net. You don't have a program. You have a product. You have a whole family of products, and you're trying to keep all these things straight. And each one of them have different versions. You know, what's one of the first things when, you know, when you're dealing with IT and trying to find some kind of a problem? Oh, wait a minute, I'm using this application version, blah, 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 and, you know, it's no longer supported. Or, you know, I'm trying to make it talk to another application version, blah, 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 and it doesn't, they don't want to talk to each other. You know, they used to talk, now they don't, right? So you're trying to just manage all this mess. Okay, what's the baseline? That's the thing that everybody agrees is the starting point. You know, you take a snapshot of the software and you say, okay, that's the baseline. Okay, can that move over time? Yeah, you might, after certain development cycles, you might say, okay, now we have a new baseline. But everybody has to agree to that. The customer, the developers, the management, people driving requirements, right? The test team, everybody has to agree to that. Okay, your project baseline, central repository. Again, notice the keys, words here: reviewed and approved artifacts that represent the stable point. So you take the picture, you take the snapshot. That's what the snapshot is. It's all the artifacts and potentially the documentation about reviewing and that did the reviewing and approving. This isn't just true in software. In industry, as you know, we have things called standards, and there are standards for all kinds of things. So when I was in industry, I was doing structural analysis, and we were getting all of our material strengths, allowable strengths, from Mill Handbook 5C, and the C was the change version. So then, you know, now it's up to Mill Handbook 5J or something like that. And we did all our testing based on Mill 810 dot whatever it was at the time. I think that was also a C. So this isn't just true with software, it's true even with standards. So if you're in a contract and they're saying, oh, you have to test to this industry standard, you know, your question really needs to be, make sure in the contract they're specifying which version of the standard. Because if you run all your tests per, you know, industry standard version 12, and they contractually wanted version standard number 13, you haven't met your contract. Okay, artifacts, software project plan, which I think we do not have, software requirement specification, which we do have, a design document, which we have, the source code, which we have, the test suite, which a lot of you teams are developing, and then the software tools themselves, which we have. So we have everything here except the project plan. Now we kind of sort of have a project plan because you've got a backlog. Okay. Now, remind me at the end of this to talk about some of these artifacts in the context of Git and other version systems. 4 elements: configuration identification, configuration control, auditing, and status accounting. Identification is just what you'd think, figuring out what you have. Sounds like an easy question, but maybe it isn't. So that graph's not right. Oh, I see, unless they created version 1.2 from 1.1.2. if you have a number of different versions, then the best way, really, I can't imagine another way to represent this in any meaningful way, is a graph structure. You know, here's the original baseline, it's basically a tree structure, is the root of the tree, and then the different branches come out. No accident that they use they use the term branching. Branch out into the different forms of that product that you're creating. So that's just identification, figuring out what you have. I don't know if you guys have ever tried to do identification on anything that's very complex. It's really not trivial. It's mundane, it's tedious, but it's not trivial. So even now, for example, for all our courses at the university, we have something called a master course outline. The master course outline has all these learning objectives for each class. Then for each class, we have a syllabus, and the syllabus has learning objectives for each class. Do they match? Absolutely not. Are they supposed to match? Yeah. So, you know, why don't they match? Because people update the syllabus, but then they don't take the time to go back and update the master course outline. So even just getting a snapshot of someone saying, okay, what is your, you know, I'm going to take the computer science curricula. What are all the learning outcomes for that? That's not trivial. Because first of all, you have to go to all the syllabi, but then you have to go to the master course outline and see what matches and doesn't match. Right? There's at least two answers to the question, what are we supposed to learn in the computer science program? Not a knock on every riddle, true of every school. That's how documentation works, or fails to work. All right, then there's control. Okay, so now how are you going to control things? Now you guys need to think about this in the context of your teams. Your teams are small, your teams are agile. What's your control mechanism? Do you think you have a control mechanism? What do you think? How is your team handling this notion of controlling what gets done to the software?
Wouldn't that be like sprint, you know, when we select our sprint goals?
Right. So you have a configuration control mechanism, which is your sprint planning meeting. And at the end of that meeting, everybody on the team ideally has the exact same understanding of at least what parts of the software are going to be changed and the goals for what parts of the software will be completed by the end of the sprint. Now, the specifics of how we'll get down into the, you know, the individual developers may solve that. But the fact that you're planning on a change, you're planning on moving your software forward in a very specific way, that's your control mechanism. And the deal with what Agile does, it doesn't throw out, you know, Agile, as you know, came around because everyone said, oh, the old way was so top heavy, so much documentation. And Agile didn't throw away those things. That's where people, I think, make the biggest mistake with Agile. Agile tried to incorporate the same things into a much more rapid response and versatile mechanism. The developer team primarily. Well, where's I going that? Oh, so all of these things still change. All of these things still exist. And what you have to worry about is if you get into a group of people who say they're doing Agile, but they really don't have a process at all. And we'll talk about even things like software requirements. Okay, they don't have any requirements at all. Not just they don't have a requirements document, but they don't have requirements. Right? They're not doing Agile. They're just flailing around making up stuff. So be aware that Agile is supposed to be a very lightweight process, but it is a process. And the problems that you have in software, particularly here, we're talking about configuration management, these are problems inherent to the software building process, and I don't care what process you're going to use. So you have a mechanism for control. Now, in a larger system, you may have a formal mechanism. So some of you have worked in industry and some of you have worked on co-ops, and you may have heard terms like change orders. Does anybody know, has anyone experienced the term change order? It's a happy term because it means your company gets money. Right? Yeah, the customer signed a contract with you, and then the customer says, "Oh, we want to change." Okay, here's the change, and they request a change, and then you negotiate with the customer. Okay, we're happy to do it, but it's going to cost you, and then you get a change order, and the change order modifies the baseline contract. And they're very common. Some companies will actually use that unethically. They do what's called buying in. They buy into the baseline contract by underbidding and knowing that the customer will change something. And then the first change order that comes down the pike, they overcharge the customer for the change order to get back to a profitable stance. So we call that unethical. They're buying in, and then when the change order comes, they call it getting well. So look out if your company's doing something like that, you might want to look around for another company to work for. Okay, then we do the auditing. What's the auditing about? Okay, so first we have the baseline of what we are at. That's the identification. Then we're going to identify what we're doing in a controlled way, and then we're going to audit to say, oh wait, has it actually been done? Has it actually, before we do it, we need to assess it to make sure it's technically correct. Has it not just been done in the middle of the night by some person in a lab and we don't know what happened, but did they actually follow our corporate procedures or our team's procedures? For example, for your own teams, what's your procedure to verify that somebody got software done? You know, you're coming up with these tasks for each sprint. Most of the tasks are software tasks, but I would recommend that you also include tasks like if someone has to update a document, something like that. But most of them are software tasks. And then, you know, what's your mechanism for convincing the team that the task was actually done, that the software was actually modified? Do you have a process? Do you have a team, a shared team understanding of what to do? It's a good question, isn't it?
Would that be the test cases?
Well, right. So how does that work? Do you guys require full test coverage? Do you require for each task or maybe for each method, at least one documented test? Or how does that work out? Because testing is a great way to demonstrate software was completed and completed correctly.
It was horrible.
Oh, yeah, yeah.
I record every single test that I did, almost every single one, and just, yeah, horrible.
Yeah, but there's mechanisms for that. In fact, Matthew had emailed me, and I need to share that with the group about, okay, he said, you know, Garfield, that sheet you gave us was too much work. We want to do it a different way. And I think we've worked out a way that his team can meet the intent of what I wanted without so much work. And I need to share that with all the other teams once I get confirmation from Matthew that we're at a stable place. I want to share that with the other teams, that if you're using like JUnit testing or some kind of automated testing unit, then it will offload some of the burden of filling out that test cases and results spreadsheet that I gave out. Okay. But you are doing testing, and then your team gets to decide, right? To what level do you test? To what level do you review test? Your team is supposed to decide that. What I would recommend, though, is that you have some expectation that there is not just an informal demonstration, but a proper documented test case for the critical things that person is doing. So when you do a task and it's a software task, you're coding the software, you have at least one formal test. And ideally, and this is tough to do because you guys don't get a chance to meet as much as you would in a industry setting. Ideally, before that person ran the test, or even before that person wrote the software, they might say, okay, I'm going to do these 5 test cases. Here, team, give it a quick look, see if it passes the reasonableness test. Now, again, the more formal the system, the more that review process is formalized. So in some companies, if you were given a task to write software, they give you the software specifications. The first thing they do is ask you to write your test cases, and your test cases have to be approved by somebody before you're allowed to start writing the software. But that's all auditing stuff, right? That's all configuration auditing stuff. And then we have accounting, which is the after the fact, long-term tracking of this stuff. It's traceability, basically, of all these changes. Who initiated the change? When was it initiated? Did we even start this thing? What's its status? Unfortunately, in a one-semester project, you don't get to see some of the issues that arise in a project or a product development that lasts longer than 12 months, 16-month, 24-month period. All kinds of time-based issues crop up. And so the accounting would be the long-term, where are we on this change? Is it complete? If it is complete, when did it get completed? Because eventually somebody's going to ask you, right? The customer asked for this stuff for a reason. Somebody's going to ask about it. So being able to establish where the status of these things are becomes useful. Okay. I'm not, like I said, I think if somebody's not familiar with these terms, I'm going to ask you to, maybe embarrass yourself a little bit and speak up, because my assumption is that most students have a passing familiarity with these terms because they've actually used something like Git or a similar thing. But if I'm wrong, I need to know I'm wrong.
I don't know much about the product modeling, building, and the workspace control part.
Okay, so the product modeling and building, that's your software design document in this class, and the requirement specifications. These are all, we refer to both of those actually as a form of modeling, because really, what does your software design document do in the end, right? In the beginning, I'm asking you for problem statements, but now you're moving into solutions. In the end, the software design document is supposed to tell you the design. It is not the design, therefore it is a model of the design. And the UML diagrams are with accompanying text are how we're describing that design in this class.
So you're talking about the SDD and SRS?
Yeah, exactly. And any other thing that might be a documented artifact of everything that's not code, although we call the code itself an artifact.
Like the class UML and the use
Yep.
case UML?
Yep, right,
Okay.
right.
Understood.
The workspace control is just physical control over the code itself. So you say, I've got a baseline, but if anybody can go in there unannounced and unrecorded and modify the baseline, you don't have a baseline. You've got a problem on your hands that has not shown up yet. So that's what the workspace control is there is a procedural mechanism by which people get access to the code and then modify the code. And again, depends on how formal your systems are. But all of these systems will have the basic check-in code, checkout code, modify it, check it back in. All of them have that basic process, capability. If it was just code that everybody had access to, then like I said, there's no configuration control at all, because anybody can change it. So side story, I worked on a software project in the mid-'80s, and we actually, in retrospect, we were doing Agile. We didn't know it. We had very little documentation. We worked in a team space. There was only 6 of us on the team. We worked in the same physical space, and whenever one of us had a question about somebody else's code, we'd yell across the room. But what we didn't have is very much configuration management. So we did have a particular, like a working set of software, and then and then a set aside pristine set of software that we were convinced was at a particular stage. But we could all mess around in each other's code. And so from that standpoint, it wasn't great. It was human discipline was providing the guardrails that you really want to have a system provide. You really should never rely on human discipline because over the long run, you know, people are going to let you down. They're going to make a bad decision. Versioning control. Now here it's about not just keeping track of their versions, but being able to roll back to previous versions, even if all you wanted to do was look at something for references. And being able to pull, maybe you say, okay, I've got this software, I've got version 1, version 2, version 3, and then you want to branch off from that and make a slightly different product for another customer. Well, intuitively you'd say, well, we're going to start with version 3 and that's our baseline, and then we're going to make a 3A and that's going to be for our customer. But it may be that maybe that customer needs something that was actually from version 1. So, you know, so you roll back and version 1 becomes your baseline for that customer. And it says here, these are Ochoa's notes, by the way. Every team must use versioning control. Okay, so I didn't put that in as an explicit requirement in the project because I don't think you can succeed in the project without some form of versioning control. And everybody loves Git these days. GitHub. Okay, so there's the Git terminology. And the main things to worry about are this notion of a repository and then checking things out, modifying the code, checking it back in. And you should be able to, you guys can correct me if I'm wrong, I would be shocked if you have, let's say you have your code is object-oriented and there's 10 different class files in there. 10 different class definitions, so you've got 10 different Java files in there. You should be able to just check out one of them, not all 10. If the system requires you to do all 10 at a time, I'm guessing you didn't set up your system quite right. You should be able to check out one piece of the code, not all of it, modify it, put that piece back in. And everything is great until things happen. What happens if I check out a piece of the code, somebody else checks out a piece of the code, we both change it, we both want to commit? How do systems handle that? How does Git handle that?
Well, that would be called a merge conflict.
Well, so here's the thing. Does it try to merge? I mean, will it take the two changes and merge them? And then notify you if it can't?
Git you will try to auto merge it if there's no like, you know, if it can, and then it'll say, hey,
right.
You got to manually merge it otherwise.
And that's the way most systems will handle that. They will allow it, but then when both of these things get checked in, they don't get checked in directly to the code. They get checked into a sandbox basically, and then the system it looks at all the changes and says, okay, I can merge these changes because what was changed in the front part of this file didn't affect the last part of the file. Therefore, I can merge these things. But if it can't automatically do it, and remember, machines are dumb, so they can't always tell if they can do it or not. But if it can't automatically do it, then it should flag the users and say, you know, I can't do this merge, I need some help. Other systems actually only allow you to have one copy out at a time. And if you try to pull a copy that someone else has checked out, it will not let you have it. That's another way to manage that. I think the merging technique is more popular because it does allow for more productivity. You can affix that in your teams too by assigning across the classes. If you're doing Java, if you're doing object-oriented paradigm, you can assign across the classes so you don't have two people working on the same class during the same sprint, right? That way you're going to reduce your conflicts. Another way things don't work is when the code breaks. So you check your code in, and then now the code doesn't work anymore. And it doesn't work anymore in a section that you didn't change. Oh, wait, that's not supposed to happen. Well, it happens. something you changed, somebody somewhere else assumed that what was in your file that you modified was never going to be different, and they created their code in such a way that it depended upon that specific configuration of your code, and you modified it, and now something that you didn't change doesn't work anymore. How do you handle those situations? What's a good way to try to prevent that from happening or detect it if it happens right off the bat?
Like documenting, not necessarily APIs, but APIs within your project. Say like, this is how we want these two modules to talk to each other.
Yeah, so you do that up front, that's right. But what if it happens anyway? Because
Testing. You just test it before you merge it.
you test it before you merge it, right? And so here's the strong case for setting up automated tests. So in Eclipse, there's JUnit testing. Does GitHub have within it the ability to basically create the test cases and store them with the software up there?
Kind of. They have support for continuous integration.
Okay.
Which does that, but it's not. That's like you basically upload the instructions for testing to the repository, and you rent out from GitHub a little runner that'll run the tests for you whenever you commit. And
you have to create your own specialized software that is running the tests.
You need to use a specialized software. Like, for example, in my like private repositories, I use Circle CI.
Okay. So there is a test management system or a test.
Yeah, it's called continuous integration.
Within Eclipse, they use the JUnit testing. You can use JUnit testing outside of Eclipse too. You just have to download the libraries if you're using Java. Basically, all these testing systems are the same. You build or integrate tests into your software, and then every time you want to commit, before you commit, you run a test, but you're running tests on everything. And the reason that that's okay to run tests on everything is because you've automated the test, you've automated the operation of the tests, which makes it really easy. So basically, as the software builds, your first time out, maybe between the 4 team members, you guys created 20 different test cases. And by the end of your second sprint, you've added 20 more. Well, you can run all 40 test cases just as easily as you can run the last one if you're using an automated test system, or if you've built your software. I've actually seen, I worked a project, it was a research project, but we were building off a really large piece of commercial code that the DoD gave us. And within that code, this was back in the days of C, and we were using make files and stuff, not using the automated like IDEs like Eclipse. But literally the test cases were built within the code, and you would put flags by them. And then when you ran your compiler, you could compile to set a flag to run as a test run or to execute it as a commercial run. So there's always ways around it. Now, these tools these days, the good news is they make life a lot easier because they do that kind of management for you. And the bad news is, it's yet another tool that you have to learn how to use. How do you learn how to use this stuff? You do this every day. The more you work with it, the better it is. The more you're forced to learn about it. And that's why I say I don't know Git. And the reason I don't know Git is because I never get a chance to really write any meaningful code anymore. So I'm not forced to use it. I guess here's the biggest use I have for Git. When people are cheating in a class by stealing code, that's usually where I find it. That's a bad use, right? So the main things here: repository where your code is, you're checking out, and you're committing. I would suspect most people aren't going to do a branch of their code in this class. You may, especially if you're building code that you like after the semester and you want to keep working on it, you may make branches of the code, which are again are different paths where the intent is not to try to merge those together in the future. They truly are slightly different variations on the product, or I shouldn't say slightly, different variations of the product. Okay, so we walked through that. The hash code is just an identifier. Checkout staging area. So again, you tend not to go directly to the repository. That's dangerous, right? To just shove code back in before it's been resolved in terms of merging and or testing. So you have the staging area and then a branch. I don't think I'm going to worry about that. There's a nice cheat sheet for Git. You can get a Git plugin for Eclipse if you guys want that. One of the things that's frustrating to me in the tech world is, you know, there's always a million variations of things. So as soon as you learn one tool, then it's like, oh wait, there's this other tool. And I'm hoping you guys are using this. I did not make it a requirement. I want your team to come up with your own versioning system. So I don't care what versioning system you're using. I hope you're using a tool and not trying to do it just purely through human discipline. If you choose to do it through human discipline, you still admit the intent of any version control. And I've not put a requirement on you. So, you know, the only problem that you can have with that is if you try to do it through human discipline is, you know, you're dealing with humans. So. Okay, so that's the course material. And hold on. Oh, what was that about how YouTube keeps track of view and like counts? What's the question?
That was in regards to the
that's-
management systems.
Okay.
Professor, you told us to remind you at the end to talk about how the software configuration item relates to Git.
Yeah, right. Thank you. See, I'm glad you did. Okay, let me do that. Then I want to get back to Brandon's question. He did say another example of the way YouTube keeps track of view and like counts, or no. So we'll put that on hold too. Okay, so here's what I'm saying about the documentation. So in this class, we're doing an SDD, we're doing an SRS, and some people that are the more extreme that Agile gets, they say, we don't even want those documents. We don't need those documents. And here's the argument that they make. You don't need a software design document because your code is the artifact. The code is self-explanatory. Now, what do you think about that?
Must be some well-written code.
Yeah,
All
I
right.
was gonna say any code that's self-explanatory probably would earn a prize.
So again, and these people, what they're doing is they're still enforcing a discipline. What they're doing is changing the enforcement from that external documentation to the internal documentation of the code. And I don't mean they document the code. I mean quite the opposite, right? They want to write code with as little documentation as possible because the code itself is so clear. So that means that they have requirements that they're putting on their software developers, very specific ways about how to write code in such a way that they believe that it's a clarifying process. And the same thing goes for requirements documents. Why would they say we don't need a requirements document? We don't need a SRS. What's the deal there? Because it's documented in the test suite. So if I have my automated test suite, all of my requirements are documented there. And if it's a really good tool, I can actually pull out the, let's say I have each test case has a requirement specification embedded in it. And if it's a really good tool and I need to have a summary, I can summarize all of my test cases, which would summarize all of my requirement specifications. But it's got to be a really good tool, right? Now, what about change order? Why, you know, we changed this, why did we change it? That kind of thing. What about that? Where do they keep that documentation? And this is, in my opinion, where most things fall down. Most of these systems don't work. What do you think? Well, when you check out, and particularly when you commit, these systems, these software versioning systems always have a, put a comment here as to what you changed, right? Put a reason, why did you change this code? Put a rationale here. And if you have the discipline that you're saying, we're not keeping track of all of our software changes through all these external documents, the change log becomes that document, but people have to really fill out that comment in a meaningful way. Now, here's what everybody says. Minor changes to code. That's not helpful. Corrected errors, not helpful. So the argument that some people make is you don't need all this external documentation because between the code and the tool that you're using, you have all that. And all you're doing by putting it in the external documentation is duplicate busy work and not helpful to the main thing, which is producing code. Now, these are the more extreme forms of agile processes that are saying that. And notice what they're saying. They're not saying we don't have documentation. They're not saying we're getting rid of process. They're saying we want the process to be more closely tied to the code, and the documentation is embedded either explicitly or implicitly in the code and in the code development process, which we can review. So it's an interesting, I think it's an interesting point of view. I don't think there's a right answer. It's always dependent upon what environment you're in, who your customers are. You know, if you're just, four people in a garage trying to make code for the App Store and, see if you can get lucky and strike it rich with a fun game everyone likes, you may not worry that much about these things, right? So you might be really light on documentation. I should say artifacts, because again, you should have the process where your documentation is somewhere. But if you're working for Boeing and FAA is your customer, you're doing design docs, you're doing software requirement specifications, and they're going to be big, thick documents, and you're going to do test cases documents and things like that. So the need for these things doesn't go away. The agile processes are just changing how they approach the solution to the problem. But the understanding that you still need requirements, you still need tested software, you still need a history that software got tested, you still need a history of how the software got changed, that doesn't go away. It just moves from the documents to the code and tool use. So I want to bring that up because too many people think that the need or the artifact goes away. It really doesn't. It's just modifying. The need never goes away. And if you're working for people who are in denial about the need for these things, then sooner or later something unpleasant will happen with that group of people in terms of their software development. So just be aware of that. Okay, then Brandon, the same way YouTube keeps track of view and like counts. I'm not sure what you're bringing out there, Brandon. We were talking about control of the software and branching.
It was in reference to how systems send out updates when you were talking about GitHub. Okay. If two people were to upload at the same time.
Okay. Oh yeah. So a couple of examples. If you go into Campus Solutions and you try to open Campus Solutions on two separate tabs, one of the tabs becomes inactive. So Campus Solutions solves the problem by saying you can only have one, I should say one application within that family of applications, by saying you can only have one thing open at a time. So if I try to do like I'm looking at, if I try to open, say, modify rosters or modify student data under my advisees, and I try to bring that student open in two pages at the same time, two tabs at the same time with the same student, then Campus Solutions knows that's a problem, and it will basically ignore or lock up the first one. But then what happens with YouTube if you say, and this is certainly not critical, how many likes does a video have? If 300 people have the video, are accessing the video at the same time, how do they manage how many likes it has at a particular point in time? That's a fairly easy one because they can put that kind of thing into a queue. And I think that's what you were getting at, Brandon, that when there are some things that you can do, you're not trying to merge at the same time. You can merge one after the other, put things into a queue. Okay.
Yes.
All right. I'm going to stop the recording now because I want to talk about class process stuff and how teams are going and things like that. So let me stop recording.